Okay students, so yesterday we had started with the problems, today continuing with the problems. The first problem for today is calculate the wavelength of an electron moving with a velocity of 2.05 into 10 raised to 7 meters per second. So here the problem is calculate the wavelength of an electron moving with a velocity of 2.05 into 10 raised to 7 meters per second. So you are given the velocity, you have to calculate the wavelength. Now which is the formula you are going to apply to find out the wavelength? Okay, we have already discussed in theory. Okay, de Broglie's equation. So de Broglie's equation can be used to determine the wavelength of the electron when you are given the velocity. Okay, so what is? First of all, before you start solving the problem, you write the given data. Then you write the formula, then you do the substitution, then you get the result. Okay, so what is the given data? You are given the velocity. Okay, so the velocity of the electron is what you have to find out? You have to find out the wavelength. So whenever you write the given data and what you have to find out, immediately you get what is the formula you are going to use. That is why you have to write the given data and what you have to find out. So it becomes easy for you to find out. So lambda is equal to h divided by m into v. H divided by m into v. So this is de Broglie's relation, okay, between the particle and the wave nature of the electron. Okay, so here you are going to find out lambda. So lambda is equal to h is Planck's constant. What is the value of Planck's constant? 6.626 into 10 raised to minus 34 joules second. What is the mass of electron? 9.1 into 10 raised to minus 41 kg. Velocity of the electron, it is 2.05 into 10 raised to 7 meters per second. Okay, so here what you do, you group the numbers together and write the powers of 10 together. Okay, so what do you get? 6.626 divided by 9.1 into 2.05 into, take the powers of 10 together, what do you get? 10 raised to minus 34. When this goes to the numerator it becomes plus, then you have minus 7. Okay, so here it is 6.626 into 10 raised to minus 34 plus 31 is minus 3. Minus 3 minus 7 is minus 10. This is divided by 9.1. See, always make the habit that you do the multiplication or division without the use of calculator. Do the approximation and do the calculation. So 9.1 into approximately 2, if you take, it will be 18.2. Right? Okay. So here you take it as 6.5 divided by 18. So 6 3 is the 18. It will be approximately somewhere between 2.5 and 3. So it will be 2.5 into 10 raised to minus 10. This is the wavelength. So it will be meters. So that is the answer. So that is the wavelength of the electron moving with velocity of 2.05 to 10 raised to 7 meters per second. Okay. Now we move on to the next problem. The mass of an electron is 9.1 into 10 raised to minus 31 kg. If its kinetic energy, kg stands for kinetic energy, is 3 into 10 raised to minus 25 joules. Calculate its wavelength. Okay, so look here students, you are given the problem. The mass of an electron is given to you. If its kinetic energy, even the kinetic energy is given to you, how you are going to find out the wavelength? Okay, so here first write the given data so that it becomes easy for you to find out the given quantity. Okay, so here mass of the electron is 9.1 into 10 raised to minus 31 kg. The kinetic energy is given to you. The kinetic energy of the electron is 3 into 10 raised to minus 25 joules. Okay, so here, now what you have to find out? You have to find out its wavelength. Now how from the given data you are going to find out the wavelength? Now we know kinetic energy is given by the formula 1/2 m into v square. Kinetic energy is given by the formula 1/2 m into v square. Okay, so here the kinetic energy is given to you. It is 3 into 10 raised to minus 25. You know what is the mass of the electron. So you can find out what is the velocity of the electron. So you take the remaining quantities on the other side. V square is equal to 3 into 10 raised to minus 25 into 2 divided by m. Okay, so here it will be 3 into 10 raised to minus 25 into 2 divided by mass of electron is 9.1 into 10 raised to minus 31. Okay, so here this will be equal to v square. So v square is equal to 3 into 2 is 6 divided by 9.1 into, you take the power of 10 to the numerator, 10 raised to minus 25. When it goes to the numerator, the sign changes and becomes plus. Okay, so here it is 6 divided by 9. Approximately you can take it as 9 into 10 raised to minus 6. So this will be 6 divided by 9. So it will be 3 2s are, 3 3s are. So 2 divided by 3 is 0.6. So 0.6 into 10 raised to minus 6. So that is okay. So here minus 25 plus 31 is 10 to the power 6. So v square comes out to be 0.6 into 10 raised to 6. So v will be equal to square root of this quantity, that is 0.6 into 10 raised to 6. Now 10 raised to 6, its square root is 10 raised to 3. Look here, 10 raised to 6, square root means what? To the power 1 by 2. So that will be 10 to the power 3. 0.6. Okay, so you know that how you can find out the square root of 0.6. It will be, suppose you take 0.2 into 0.2, that will be 0.04. What you want is 0.6. Okay, so here this value, it will lie somewhere between 0.15 to 0.15 approximately. Okay, so here that will be the velocity of the electron. Now using the velocity you can find out the wavelength. How you can find out the wavelength using the velocity? Again you are going to use de Broglie's relation. So what is de Broglie's relation? Lambda is equal to h divided by m into v. H divided by m into v. You know what is the value of Planck's constant, you know what is the mass of the electron, you know what is the velocity of the electron. So substitute the values and find out the value of the wavelength. You can do it yourself. Okay, so we move on to the next problem. electron is in one of the 3D orbitals, give the possible values of N, L and Ml for this electron. Okay, so pay attention here. An electron is present in the 3D orbital. So you have to find out the values of N, L and Ml. Now you should know what N, L and Ml stand for. Okay, N stands for principal quantum number, L stands for azimuthal quantum number, Ml stands for magnetic quantum number. Okay, so here the electron is in 3D orbital. I told you the number indicates the principal quantum number. So value of N is 3. Okay, L. For the given principal quantum number, the value of L lies between 0 to n minus 1. 0 to n minus 1. Okay, so substitute the value of N here. So L is 0 to, this value of N 3. 3 minus 1. So L is 0 to 2. That is from 0 to 2, 0, 1, 2. 0, 1, 2. Okay. So here these are the possible values of L. Ml. Now these are the possible values of L. But since here it is in the d orbital, the electron is in the d orbital, the value of L will be 2. Okay. L is 0, S subshell. L is 1, P subshell. L is 2, D subshell. Right. So the value of L is 2. Next, the value of Ml. The value of Ml depends upon the value of L. Okay, so value of Ml lies between minus L to plus L. Minus L to plus L. So, what is the value of L here? For the d orbital it is 2. So, Ml is equal to minus 2 to plus 2. Means you have to include 0 as well as 1. So, it will be minus 2, minus 1, 0. Plus 1 and plus 2. So these are the values taken by the Ml corresponding to 5d orbitals. dx1, dyz, dxz, dx square minus y square and dz square. Okay, so that is regarding the 9th problem. Okay, moving on to the next problem. Using SPD notations. Describe the orbitals with the following quantum numbers. The first one, n is equal to 1, L is equal to 0. The second one, N is equal to 4, L is equal to 2. The third one, N is equal to 4, L is equal to 3. And the fourth one, N is equal to 3, L is equal to 1. Okay? 2 of them I said I shall solve for you, the remaining 2 you will do it from homework. Okay. So here we are using SPD notations, describe the orbital using the following quantum numbers. So the first one given to you is n is equal to 1, L is equal to 0. Okay, so here n is equal to 1, 1 means what? The electron belongs to the first main shell. L is equal to 0. L represents the subshell in which the electron is present. Right, so here the principal quantum number you write as it is, that is 1. L is equal to 0 means S subshell. So it will be 1s. The electron is present in the 1s orbital. Okay, the first one. The next one, n is equal to 4. Now this n is equal to 4 represents the main shell to which the electron belongs. So n is equal to 4. L is equal to 2. L represents the subshell in which the electron is present. So L is equal to 2. Just now as we discussed, L is equal to 2 corresponds to the subshell. So it is the 4d orbital. Similarly, you can do the remaining 2. N is equal to 4. L is equal to 3. N is 4 and L is 3. L is 3 means it has to be F subshell. So this is 4F orbital. N is 3, L is 1. It means this is 3p orbital. Okay, so you can easily solve this. Okay, we shall stop there for today. That's all regarding the chapter structure of atom and its problems. Okay.